So in this double lesson, we're going to be looking at sequences, but first of all, we'll spend 10 minutes on this do now. Pause the video and have a go at the questions. When you're ready, reveal the answers. If you're not sure about any of these answers, please just email me or ask in the next lesson. So sequences, we start off with linear sequences, and just pause the video and choose which of these answers is the nth term for this sequence. And hopefully you chose C. If we look here, we are increasing by 3 each time. So from that, we can write 3n. And then to get from when n equals 1, 3 times 1 is 3. To get from 3 down to our first term of minus 8, I'm going to have to subtract 11. Okay, so basically that's what we do. We look for the term-to-term rule, whatever we are adding or subtracting each time. We put that in front of n, and then we see what we have to add or subtract to get to the first term. So a few more examples. Here I'm adding 7 each time, so I can write 7n. To get from 7 to 8, I add 1. In the next one, I'm adding 7 each time, so I write 7n. And then I'm already there. I don't need to add anything. And that's my 7 times tables. In the next one, I'm subtracting 5 each time. So it's minus 5n. To get from minus 5 all the way to 15, we need to add 20. And in this one with decimals works as well. I'm adding 0.3. So I write 0.3n, and then I need to minus 0.1. Pause the video and have a go at these questions. And hopefully you got these answers. And so finally, have a go at this one. And hopefully you chose D, minus 2n minus 6. So that's how we find the nth term of a linear sequence. What we can then do is use that to answer these sort of questions. Is 100 a term in the sequence given here? So the first thing we do is we're going to work out the nth term of this sequence, and we're adding 4 each time, so it's 4n plus 12, and we want to see if there is a value for n, an integer value for n, where that is equal to 100. So if we subtract 12 from both sides, we get 4n equals 88, and then we get n equals 22. So our answer is yes, 100 is in the sequence, is the 22nd term. Is 89 in the sequence? So next question. Here I'm adding 3 each time, so I've got the sequence 3n plus 30. And I want to see if there's a value for n, integer value for n, that gives me 89. So subtract 30, I get 3n is 59. Divide that by 3, and I'll get n is, what would that be? 19 and 2/3. So no is the answer to that one. The 19th term would be less than 89. In fact, the 19th term is 3 times 19 and then add 30, comes in at 87. And the 20th term would be 3 times 20 is 60, and then add 30 is 90. So 89 is not in the sequence. Okay, so your turn on this one. with that challenge there. And we get that as our answer. My second question there was around is the first term to exceed 1000. So if we use this 4n plus 22 equals 1000 and we solve that, we get n is 244.5. Now n has to be a whole number, so it'd be the 245th term. Plug in n equals 245 into my nth term, tells me that comes out as 1002. It's the first term above 1000. If you need more practice on this, please have a go at these questions, some or all of the questions, as much as you feel you need. We skipped this in class, everybody felt very confident on that. So if you want to have a go, pause the video and then play for the answers. Otherwise, we'll skip forward. Okay, this was quite a nice question, exam question. Have a go at working on this. So first thing we can do is write out the terms of the sequence. Beyond 91, they go into 3 digits, so we can discount those. We can cross out 7 as it doesn't have 2 digits. And now we want to know which ones of these are prime or not. So if they're prime, we're going to cross them out. So 19 is prime, we'll cross it out. If we're not sure if it's prime, you can use what I showed you last lesson, and you use shift on your calculator, type in the number 31, shift equals to get it in the display, and then press equals 31 in the display, and then shift fact. Find the button on your calculator that's got fact in yellow above it, and then if when you press that it stays 31, then we know that it is prime and we can cross it out. We find 43 is prime, so we cross it out. 55 is not prime, so again, if you did that on your calculator, press shift fact and it will return 5 times 11. That's the prime factorization of that number. If you do that for 67, that's prime. 79 is prime. If you do it for 91, we get 7 times 13 is the prime factorization. So that's not prime. It's multiples of 7 and 13. That's not prime. So there are 2 answers for that question. Okay, I'm going to move on to quadratic sequences. So you might want to take a break for a bit. We're in the second part of the lesson. So quadratic sequences involve n squared, with our most fundamental being the straightforward quadratic sequence that basically generates square numbers. If we put n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, we get 1 squared is 1, 2 squared is 4, 3 squared is 9, 16 and 25. So we're going to keep on coming back to this quadratic sequence. So, and if we recognise that it's a quadratic, and I'll explain a bit more in a minute, then we can often compare it to n squared to work out our nth term. So if I'm given this sequence, 2, 5, 10, 17, 26, and you look at the relationship between that and n squared, you might see that each of these terms is simply added 1. So my nth term rule would be n squared plus 1. If we look at the next sequence, again comparing it to my original n squared, I've got 1, 4, 9, 16, 25. So here 1 to -1, 4 to 2, can take away 2, 9 to 7, subtract 2, 16 to 14, subtract 2, and so on. I get n squared minus 2. Look at the next one. 2, 8, 18, 32, 50 is just double n squared. And there's my nth term rule. Okay, so you could have a go if you want at trying to spot these quadratic differences. Pause the slide, pause the video and have a go at writing them down. Top one is just n squared, so see if you can compare them to that one. And hopefully you got some of these answers. Okay, we're going to go into some more complicated quadratic sequences. First of all, write out the first 5 terms of each of these sequences. So we just put in n equal 1, 2, 3, 4, 5 to work out what these are. So n squared 1 we can just write down, n squared minus 3 you can write down from that, and probably 2n squared, just double in each of the terms. Next one's a little bit trickier to work out. Do have a go at working those out. Just substitute in n equals 1 to 5 to work out the terms. Just pause the video, have a go. And the answers are 2, 7, 16, 29, 46, and 2, 7, oh, they're not the same sequence, hold on. Sorry, and that's the answer for the bottom sequence that you should get. Okay. Okay, when we're looking at quadratic sequences, how we know it's quadratic is we can start that there's patterns that occur, and it's basically to do with the second difference. So if I just take this this one here, n squared, to get from 1 to 4, I add 3, 4 to 9, I add 5, here I'm adding 7, here I'm adding 9. That's my first difference. If I then look at, and you can see a pattern, 3, 5, 7, 9, we would then add 11, 13 and so on. What we're doing is we're adding 2 to the difference each time. So this is what we're calling our second difference. My first difference, add 3, 5, 7, 9. My second difference, add 2 each time, so it's constant. If I look at the next sequence here, this is add 3, add 5, get the same pattern, add 7, add 9, and here my second difference, add 2, add 2, add 2. It changes slightly on the next one. Let's have a look here. My first difference, add 6, add 10, add 14, add 18, and I can see my sequence here, 6, 10, 14, 18 is going up in 4s each time. So the next one would be add 22, and so on. So here my second difference is add 4. Add 4, add 4, add 4. I find in the next one, my second difference is also add 4. So 2 to 7 is 5, add 9, add 13, add 17, and again my second difference in green here, I'm add 4, add 4, add 4. And this last one is different again. Here I'm adding 7, then I'm adding 13, then I'm adding 19, and then I've added 25. If I look at my second difference here, from 7 to 13 I've added 6. Here I've added 6, here I've added 6. So if I just make a note here of what my second difference is, for these n squared sequences, my second difference is add 2. For these 2n squared sequences, my second difference is add 4. And for a 3n squared sequence, my second difference is add 6. So this gives me a little rule that basically if I'm given the terms of the sequence, I first of all check that it's quadratic by finding the second difference. Then if I halve that second difference, that tells me the coefficient of n squared that I need to work with. And this is really powerful and for then finding what the nth term is. So here is our sort of method for finding the nth term of a quadratic sequence. A lot of it is going to come down to your layout, and if you lay it out in the same way each time, it becomes quite easy. Okay. So first of all, I'm given this sequence 5, 4, 5, 8, 13. It looks a bit strange to start off with. Let's have a look here. I'm going to minus 1 and then plus 1. Plus 1. Then from here, I'm going to add 3. And here I add 5. So originally the sequence looks a bit strange, but when I've looked at the differences, minusing 1, then adding 1, add 3, add 5. I can see I'm probably going to add 7, add 9 from here on in. If I look at this, my difference here is 2, add 2, add 2. So I've got that my second difference is constant, and if I halve that, I get 1. So this has to relate to the sequence n squared. So what I'm going to do is I'm going to first of all write out my sequence n squared. So I get 1, 4, 9, 16, 25. I'm now going to leave a gap, and I'm going to get the sequence that I'm trying to find the nth term of, which is 5, 4, 5, 8, 13. What I'm now going to do is say, well, what am I going to add? I'm specifically saying add as well all the time. N squared plus something to give me the bottom sequence that I'm looking for. So here I'm going to do 1 plus 4 would give me 5. 4 plus 0 would give me 4. 9 plus minus 4 to give me this term. 16 plus minus 8 gives me that. And 25 plus minus 12 gives me 13. Now, if I have a look at this sequence here, it is linear, like we were looking at before, and I'm subtracting 4 each time. So this sequence here is actually the sequence minus 4n plus 8. So I know that if I've got the sequence n squared and then I add the sequence minus 4n plus 8, I will have my sequence at the bottom. So my answer to the nth term of this sequence is n squared plus minus 4n plus 8. Do another example of that on this one. Same principles here. So I'm going to write in my first and second differences. So plus 0, plus 4, plus 8, plus 12. I can spot the pattern here, and I can see my second difference is constant, and I am adding 4 each time. If it's adding 4, that implies that it relates to 2n squared. So the first job is to write out the sequence of 2n squared. Personally, I would always start with the sequence n squared. 1, 4, 9, 16, 25. then write 2n squared, so I'm doubling it, 2, 8, 18, 32, 50. Ignore the n squared above it now. So I've got 2n squared. I know my sequence above relates to that. What am I going to add to that sequence to get the one that I've got at the top? So 4, 4, 8, 16 and 28. I want to add something. So 2 plus 2 is 4. 8 plus minus 4. 18 plus minus 10. 32 plus minus 16. 50 plus minus 22. So if I add these two together, they will give me that bottom one. So now I look at this green one that I've written. The nth term of that, I am subtracting 6 each time. So this is minus 6n. And then to get from there to my first term, I need to add 8. So here is my green sequence, as it were. So my bottom sequence comes from 2n squared minus 6n plus 8. So there's my nth term there, 2n squared minus 6n plus 8. Okay, your turn. Have a go at this one and see how you get on, and then I'll go through it as well. So pause the video and have a go. Okay, so we'll go through the same process. First of all, show our first and second differences. So 11 minus 3 is 8 minus 9 and minus 15 and minus 20, what we're up to, minus 21. If I look at my second difference here, it's minus 6, minus 6, minus 6. Right, half of this gives me my coefficient of n squared, so this has to relate to minus 3n squared. So a bit of a trickier one, this one. So here we go. So start with my n squared. 1, 4, 9, 16, 25. From there, I want minus 3n squared. So just multiply each of those numbers by negative 3. So I'm going to get minus 3, minus 12, minus 27, minus 48, and minus 75. Right. So this is one of the key things that my sequence relates to. I'm going to write my sequence out underneath it that I'm trying to find the nth term to. 11, 8, minus 1, minus 16, minus 37. Okay, so I'm going to try and find what I'm going to add. Minus 3n squared, so minus 3 plus 14 would give me 11. Minus 12 plus 12 plus 8, so plus 20 gives me the 8. Minus 27 plus 26 gives me minus 1, and we can see the pattern here. So this should be plus 32, but do check. Minus 48 plus 32 does give me that. And then adding 6 here, so this should be plus 38. And again check. Minus 75 plus 38. So minus 45, minus 37, that works. Okay. We'll now look at this sequence. I am adding 6 each time, so it's going to be 6n plus 8 to get me to 14. So there's my middle sequence there. So my overall answer to this is minus 3n squared plus 6n plus 8. Well done if you got that. If you didn't, don't worry, it takes a bit of practice. Have a go at some of these questions on the next slide. Take your pick. Pause the video, have a go, or answers on the next slide. So once you've answered 1 or 2 questions, check the answers and flick backwards and forwards. So And well done. There's the answers.